Hello and welcome back. In this video, I'm going to go over the FreeU node. First, I'll briefly go over the FreeU paper, then outline the difference between backbone B and skip connections S. Once we understand how the values work, we can start performing a grid search starting with the B1 and B2 values, then progressing on to the S1 and S2 values. I'll show my attempt at doing this using ComfyUI ComfyRoll custom nodes, but also show the bug occurring when attempting to create the XY grid. As a result of issues with the ComfyRoll nodes, I employ another methodology utilizing the ComfyUI API in which I show how to programmatically queue prompt the images, then create a functional XY grid afterwards. I repeat the process for both the official LCM LoRA and the SDXL Turbo LoRA that I extracted myself. If you're interested in increasing the image quality of your generations or exploring the ComfyUI API, let's get started. First off, what is FreeU? FreeU, or Free Lunch and Diffusion Unit, is a method that, in the author's words, substantially improves the generation quality on the fly. It's a bold claim, but let's go ahead and take a look at the paper. Right off the bat, in Figure 1, we're greeted with vanilla images and images generated with FreeU applied. From my observation, FreeU seems to increase the saturation of the image as well as sharpen up the details. It also appears to clear up any deformations in the image. This one is the most evident example, where the teeth are set properly. Anyway, the first notable observation the authors make is in Figure 2. So this one, the denoising process. You can see that the image generations proceed from left to right, going from very noisy to refined image. The first row is the standard image generation we're used to. The second row is the low frequency being denoised. The second row is the low frequency being denoised. The authors point this out to show that the low frequency handles the global or general gestation of the image. If you're familiar with sculpting, this would more or less equate to the primary detail. The third row is the denoising of the high frequency image, which handles the fine details. In the same vein of the sculpting analogy, this would be secondary detail, but it leans more into tertiary detail in my opinion. Later on in section 2.2 in the methodology, the authors define the low frequency data to be denoted as B for backbone, and the high frequency data to be denoted as S for skip connections. Skip connections should be a familiar term, but let's go ahead and refer to the Stable Diffusion paper for a quick review. The skip connection S, or the gray arrow here, passes features from earlier layers of encoder blocks directly to the decoder, hence the name skip connection. Right after this section, the authors mention that in Figure 5, changing the backbone B value enhances the quality of the image, while changing the skip connections S doesn't impact the image quality of the generated images. However, that's not to say that skip connections don't have their place in overall aesthetics. Next, the authors make an important discovery in Figure 6 on the right here. The graph shows that increasing the backbone scaling factor results in suppression of high-frequency components in the images generated by the diffusion model. So if you forgot or don't remember, the high-frequency components are the secondary and tertiary details of the image. So the S values or the skip connections control how much detail actually goes into these areas. Basically, Figure 5 conveys that the higher the B value, the less detailed the image will be. This makes sense if you recall that a higher B value means more of a focus on primary detail, which could be, in turn, a flatter image. Conversely, when the S values are gradually increased, it might be difficult to see, but you can kind of make out more of these grainy details in the images the higher you go. As such, our method of tuning FreeU becomes extremely simple. The B1 and B2 values are the values that control the overall image composition, while the S1 and S2 values control the finer details. If we reframe the order of these variables, tuning FreeU becomes a very simple grid search problem where we first vary the B1 and B2 values for our model in question until we get the ideal B1 and B2 values that work for us. Then, we keep those B1 and B2 values static and vary the S1 and S2 values. Simple. Now that the crash course theory is out of the way, let's get to the practical side of things. I'm going to show you two methods to tune your FreeU settings. The first method will use ComfyRoll custom nodes, and the second method will employ the ComfyUI API. I ended up going with the ComfyUI API in the end. The reason will become apparent after I show you the ComfyRoll custom nodes and their deficiencies. People claim that the ComfyRoll nodes will be able to create image grids for whatever you want, but I have found that this is not working properly for me. If we go to the GitHub issues on the ComfyRoll nodes page here, and then search up XY image from grid, like so, you can see there's one closed issue. Go ahead and click on that. And if you read through it, there is some documentation or something similar to documentation on CivitAI. So let's go ahead and open that up. In addition to the CivitAI workflows for ComfyRoll, there's also a YouTube video. If we go back to the GitHub issues and click on this, it's created by this person named Grokster, and he shows us how to use the ComfyRoll nodes for plotting CFG versus seed. So I think he has a diagram here. CFG for the x-axis and seed for the y-axis. However, the key difference here is that he uses the CRXY list node, whereas we want to use the Comfy XY interpolate node. More on this soon. So let's head back to the CivitAI page and download the zip file here with all the workflows. Once you download the workflows from CivitAI and unzip them, you can see that coincidentally there are two FreeU demos right here. So let's drag this into ComfyUI. Here we go. Drag in. There it is. There's something called a mile high styler here, which I'm not going to use, so I'll just delete that. I'll also change the checkpoint to use my own fine-tuned model. So right here, that. All I changed was setting up these prompts like usual. And now let's go ahead and take a look up here, which are the ComfyRoll custom nodes. This is the ComfyRoll XY interpolate node I was speaking about earlier. We have this primitive over here that controls how and when the node starts from. So it says to use index 1. And if you're using index 1, it'll end at index 12 because the reasoning is you have 3 columns and 4 rows. So 3 times 4 is 12. And hence your ending value should be that to match up properly. After that, there's only one thing that we really have to look at is the output folder and the save. So right here, the save image is going to be in the folder called FreeU. You have to create these folders, FreeU, and then also create this XY grids as well. So like that, I've already done that for both. Please recall that I haven't made any changes aside from changing the prompts. This is just straight out of the workflow. And to run this, since we have 12 here, we're going to need 12 for the batch. So to enable that, go to extra options, enable this checkbox, and type in 12 here. And one more thing is we should have a stable seed somewhere. So yes, fixed seed is already fixed. This is important. And one more thing is that when we run this, you will see this counter up here jump up to 13 because it will add 1 plus whatever end index is here. So let's go ahead and do it now. See the counter going up, 13. So the generation has finished and we can go over here and look at this grid. Weren't there supposed to be 4 times 3 equals 12 images here? I only see 11. Why is that? What is going on? How come this grid is created before the final image? That doesn't make sense to me. What is going on? I don't know. Perhaps this is a visual glitch. So let's go ahead and consult with our actual folder viewer. Let's go here and go into FreeU. How many images do we have? 4, 4, 4, 12, yes. Let's go over to XY grid here, open that up, and 11 images. Something is wrong in the workflow. So let's go back and investigate. We're back in ComfyUI. The first thing we need to do before doing anything else is resetting this counter back down to 1. Otherwise, we won't be able to get a grid of anything because this counter keeps track of which images go where. Next, what if we change the start index to 0? Will that make sure that every image is included in the final grid? Well, there's only one thing to do, and it's to find out. Once again, batch count of 12, and let's generate. The generation has finished once again, and if we look here at the grid, there are 12 images here. However, if we look even more carefully, this is the 11th image. I think the 11th image is repeated down here again, while it should be this image. Is this image present anywhere in this grid? Let's check. I don't believe so. I don't see it here. So if you start from the index of 0, you do end up getting 12 images. One of them is repeated. And one more thing, you're missing the x-axis for the labels. So what is going on here? And how do we fix this? There's some kind of interference with this XY from folder node. If we go ahead and consult the video put out by Grokster, you can see that he is using the XY list instead of XY interpolate. Let's try this before writing off the ComfyRoll nodes. There's a few things that we have to do first. Let's go ahead and move this XY interpolate node up here. We can disconnect it if we want. So just like that. Rotation and trigger. That looks okay. Now let's go ahead and create the XY list. Double click, CR XY list. There we go. Probably need some more room. And don't forget to move this start index back to 1. Very important. And now in here, we have to manually enter the values that we want. So no longer do we have XY interpolate doing this for us. You can look at this for reference. So 0.9, 1.1, 1.3, and 0.8 to 1.1. I've finished typing in those values that we need. Now we have to connect this index back to the primitive. So go here, right click, convert index to input, and just drag this over. You can see it's back at 0. We have to go from 1. Next up, we have the annotation. We can just straight up connect these, as well as the trigger, like that. We just have to connect these XY values into the FreeU node now, down here. However, there's a bit of a gotcha here because we're working with text. This is all text, and we have to convert that into a number and a float. So let me just make some room over here. So we need text to number, like that. And then let's go ahead and clone that because we'll have 2 of these. And then we also need a number to float, like so. And we need 2 of these as well, like that. So the top is X and the bottom is Y. Just drag those over here. B1 and B2. And I think that's it. So let's go ahead and generate once again. Remember batch count 12. 1, do another check, 1 to 12, good. Okay, looks good to me. We can go ahead and just delete the interpolate node, don't need that. And if we want to see what's going on, just connect these to these. The generation has finished, and if we go over here and take a look at the grid, or click on this, you can see that the same issue is happening where the last image is not here. The grid is being generated before the final image can be added. And also you can see this time it's not prepended detailing what this is. The top is B1 and the y-axis is B2. So you can prepend here on your annotation if you need that distinction, which you probably do. But I don't know why this is not working for me. In the video here, it's clearly working. And I am updated on everything for the ComfyRoll. It's using the latest update from GitHub, so I don't know why this issue is happening to me. What do I do now if these ComfyRoll nodes aren't working for me? Let's go ahead, take a step back, and put on our thinking caps. In both cases of XY interpolate and XY list, the images were being generated properly. Likewise, in both situations, the grids were being created with n-1 images, where n is the total amount of images. This leads me to believe that there is some kind of issue with the XY save image grid node, or it could be an asynchronous issue. With that being said, let's go ahead and open up the second FreeU workflow here from CivitAI, and you can see there's an XY from folder for FreeU demo. Drag in this workflow, replaces it. This looks pretty similar to what we have, but remember that here it should be not 1.2 to 1.5, but these values instead, like that. And I guess we have to retype this B2. If you go back and look at the original node, they're separated by semicolons and not commas, and give it another try. And there we go. Finally, a working graph. 0.8, 0.91. If you want to go ahead and use the ComfyRoll nodes, you will have to manually input your values here. And if you're using XY interpolate, you'd have to do the same thing here as well. Since I mentioned that I'm not a big fan of manually entering lists or two-step workflows, I thought to myself, for my own personal sanity, is there any way I can get around this issue? Luckily for me, if you head over to the ComfyUI repository, you can see here that there's this conspicuous update how to get the prompt in API format in the example commit. What does the script examples directory have inside it? Let's go ahead and check it out. Inside, you have a basic API example Python file. Very interesting. Once you go in here, the very first comments are, this is the ComfyUI API prompt format. If you want it for a specific workflow, you can enable dev mode options by clicking on the gear. Why don't we go ahead and try that out? I have a basic SDXL 1.0 workflow loaded up here without the refiner connected, and it's using FreeU up here in this node. So FreeU comes right after the loading of the checkpoint in the order, and here we are. So how do we enable dev mode options? Let's go over here, click on the gear, this comes up, and we have this checkbox here, enable dev mode options. Click on that, escape out of here, and then you can see in the bottom right corner, there's a save API format right here. So let's go ahead and click on that, and then find a place to save your JSON file. So for me, I've already done so, but I usually like to keep them together. So it's in here, here, and I've saved it as this one, custom save API. And one thing to notice is that these API files are considerably smaller than the workflow files, even though they're both JSON files. This is the file that we just saved. So you can see that it is the API JSON file, and this probably doesn't make too much sense to you yet, but let's just go ahead and get familiar with it. So you have these numbers here, and I believe they represent the ID of the node. So you can see 24 is this text multi-line. Go around and look, we have a save image one, image save on node 63. So how do we make sense of all of this information here? And how does it look like when we compare with the non-API version? And the non-API version, it's roughly the same. However, it seems to be a lot more verbose. And there's probably a lot of things that aren't really relevant, like this reroute node. I don't think I saw any of that in the API here. Let's just check. Reroute, none. Pattern not found. It looks like the API file only has the most relevant, pertinent, bare bones information for the workflow. Now that we see that every node is indicated by an ID node, let's go ahead and go back to the example scripts. Once we make our way past the initial comments up here and scroll down all the way to the bottom, the plot literally thickens. Starting from line 103 to the end, you can see several things of note happening. First off, there is a method named queuePrompt that sends a post request to your ComfyUI local host address and port with a /prompt appended to it. Then you can see that the prompt simply functions as a dictionary or object. You can change the values depending on the node number, as you can see here. In the first example on line 112, the ID is 6 and it's manipulating the text input. So let's go to ID of 6 and you can see it's the clip text encode. Inside the dictionary for the key of 6, you can go to inputs, which is another dictionary or object, and then you have text, which you can change to whatever you want. This is the base, which is masterpiece, best quality girl, And you can see here that it's being manipulated to masterpiece best quality man instead. In the same vein, for the second example here, which is the ID of 3, we can go there and we're changing the inputs of that and specifically the seed number. So right here in the default, we have this value here, 8566257. And down here, we are overriding that seed value to a simple integer of 5. It's all coming together now. Now that we have a little bit more context about the API JSON file format, we can head back to the API JSON that I saved. Please recall that this workflow has the FreeU node added, and it's down here in node number 51. So here, and you can see there is B1, B2, S1, S2. And the class type is FreeU v2, the newer version of the FreeU node. In my own script, all I'll have to do is just programmatically change the B1, B2, and S1, S2 values. Once the images are generated, I can then create my own grids and search for the best values. Here is the final script that I'll be using. There isn't anything really special about it, as it's just a more advanced version of the script examples shown in ComfyUI repository. The first thing that I do is load in the API JSON file as opposed to defining prompt text here. On line 39, workflow equals json.load. Then I create temporary variables that will store the particular values of the node ID in the workflow that correspond to FreeU, ksampler, and save image, or image save. Note that I'm not using the save image node, but the image save node, so I should rename this, but I didn't. Using the image save node allows you to save to a specific directory, namely the current date time. This is how I set it up in Python. And let's just go ahead and take a look at the nodes once again so you can see. This is the API JSON file, and you can see in node 63, the last one, there is an output path. This is normally what's going to happen, but I've just overwritten it with my own. To find the ideal values, please recall that I mentioned that this would involve a two-stage grid search. The initial step will be to find the ideal B1, B2 values. Once we settle on those values, we will keep those B1, B2 values and then vary the S1, S2 values to find the final optimal parameters. In the code, that's performed down here when I specify dynamic values type. In the case where dynamic values type is B, the S1 static and S2 static values will be loaded in alongside of it, with the B1 and B2 range being a plethora of values, and vice versa when the dynamic value type is S. For now, let's concern ourselves with defining a B1 and B2 range and keeping the S1 and S2 values static. However, we need some kind of baseline for these S1, S2 values. Otherwise, no matter what B values we search for, everything will look atrocious. So how did I come to this value of 1.1 and 0.2? Well, that's easy. Let's just go to the FreeU repository. Here we are on the FreeU repository page. If you scroll down to the end, you can see here under the SDXL section that there are sample values. The suggested values for B1, B2 respectively are 1.3 and 1.4. The suggested values for S1, S2 respectively are 0.9 and 0.2. I did some testing on my own, and I found that I liked 1.1 and 0.2 for S1, S2. In addition, you can see that there is range for more parameters. You can consider 1 from 1.2, 1.2 to 1.6, and anything below 1. However, I did more of an extensive test because I wanted to see what exactly the kind of results I would get using different values. Before we execute the code, let me briefly touch upon the architecture of the grid creation process. Since I was already alerted to the pitfalls of the ComfyRoll XY grid asynchronous issue, I made sure to handle that in my own script. Since you can calculate beforehand how many images you will generate, so here you can see run image creation process, and expected image count are the length of the X range and Y range, where these are dynamic values depending on whether it is B or S. Once you calculate the total amount of images or expected image count, I set up a polling system where I will only create the image grid once I have found the total amount of images. So you can see this wait for directory creation function right here. I set the refresh rate to 5 seconds over here, so wait for images, and then a 5 down here, time.sleep 5. So the image searching will commence every 5 seconds. If you make the overall polling wait time long enough, so let's go back up here, image generation timeout, this will also eliminate the issue of having to deal with asynchronous requests with the queue-prompt post request itself. So there are 2 more things I want to mention. If you're running your script from inside Linux on Windows Subsystem for Linux 2, then you'll have to make these changes. The first is in environment variables over here. You want to get the IP address of Windows because you're in Linux, and inside Linux you have localhost, but on Windows you're not using the localhost. So for me, it is 192.168.64. To get this value, you need to run a special command in Linux. I'm in my Ubuntu workspace right now, and the command you have to run is this one, grep name server. Once you enter that, you can see 192.168.64.1, and that is my IP address. If you're using the ComfyUI pulled from the repository as opposed to using the portable executable, then what you'll have to do is change your runconfy.batch file. I'm not sure if this is default or if I made this file, but it's a batch file. And inside here, I'm running these commands, which is activating the virtual environment and then running python main.py with, this is important if you want ComfyUI to be available everywhere on LAN. So remember, --listen is key if you want to call the API from inside your Linux distro. Before executing the code, we should see what is happening. We'll have the dynamic values type be, and if this is the case, you'll have S1 static and S2 static being loaded in, which is 1.1 and 0.2. For the B1, B2 range, I have both of them going from 0.4 to 1.7. If you calculate that, that is going to be 14 values, including both endpoints, because it's incrementing by 0.1. So we should have a grid with 196 images on them. Here are my 2 terminals. On top, we have Ubuntu Linux, and down here we have Windows, which is where my ComfyUI is. So first up, let's start up the ComfyUI server. For me, it's this. Okay, it's looking good for me. And now let's go back to Ubuntu. Now in Ubuntu, let me go ahead and activate my shell script, which is this one. This will activate the virtual environment like so. And now I can go ahead and run my tuning script. Before I execute this, please take notice down here because it will receive an influx of queue prompts. Here we go. And you can see all these got prompts, and it's waiting for the first directory to be created. On the first image generation, you're going to create a directory. Once that directory is found, it will tell you. So the first generation is happening. Look carefully because it will ask you about the directory here. See, the path doesn't exist and it will create it on its own, and then you can see up here that the directory has been created and it has been found. Now it's just waiting for all of the 196 images to be generated. So let's go ahead and just wait for that to happen. Let's go ahead and analyze the results. I'm in my image viewer here right now, and I believe this is the folder with the output. If we click on any image, we can see down here that it says 197 objects. That makes sense because we should have 196 images and 1 image grid. Let's scroll all the way down. And yes, we have an image grid. Click on that. And we have this very high resolution grid. I'm going to take this into Photoshop and do some more analysis. Here is the plot in Photoshop. I've added some annotations that I'll show you eventually. When the B1 value is low, so 0.4 to maybe 0.8, the images look pretty bad. They seem very sketchy. So why don't we just start with B1 at 0.4 and continue down on the y-axis, increasing the B2 value. Let's just keep going down, down. When B2 is around 1.3, we start to get some form defined. This is much better than this. And if we go all the way down to the bottom at 1.7, you can see that this is very reminiscent of a cooked LoRA or overbaked LoRA. I would say that this is still not very great, but it loads better than what we had up here at low B2 and B1. While we are down here, I would like to point out a trend. when B2 is extremely high at 1.7, increasing the B1 value doesn't seem to have such a great quality impact in this entire stretch. You can see that nothing's really changing here. Same, just very minute improvements. Only when it's around 1.1 do we start to get a big jump in quality. B1 at 1.1, 1.2, and 1.3 are good areas to look at to see when there is a jump in quality. Already here from B1.2 to 1.3, you can see that the hands are becoming defined and the face is not as bad. So let's go back to up here where I was speaking about 1.1, 1.2, and 1.3. 1.3 is my pick for seeing a dramatic increase in image quality. So let's just keep it at 1.3 and just keep going downwards, increasing the B2 value. Keep going and keep going. Once we hit here, which is when B2 is 1.3, is when I think it's a good place to stop. If I go any further, you can see that there's more artifacts here. So let me highlight these. There's an artifact here on the eye, entire face, and lastly at 1.7, it just seems very overexposed. However, it's not too bad. I would say nothing that inpainting can't fix. And there's one more thing that I want to point out, which is increasing the B2 value seems to saturate the image. Increasing the B1 value also saturates the image. If we go back here, this is the image I stopped at. Right now we're at B1 1.3 and also B2 1.3. If we progress to the right, the image is getting better. And then if we go one more, I would say this is very good. And then if we go one more, the image composition has changed. I'm not sure how much I like this image. Not very much. And then one more, and this is too much loss of the features for me. So I'm thinking B1 at 1.5 and B2 at 1.3 is a pretty good range of values to use for the static B. However, there's one more thing that I want to handle, which is narrowing these values even further. Right now, we're using an increment of 0.1, but I want to lower this increment even lower to 0.05 to make sure that we're honing in as accurately and as precisely as possible. So let's get to it. Now that we have a general range of values to search across, let's go ahead and run that as well. The second pass will be to search from B1 1.3 to 1.7 and from B2 1.1 to 1.7 for a narrow window. So make sure that you comment out the previous B1 B2 range, which was 0.4 to 1.7 on the increment of 0.1. and enable this one, which has a lower increment of 0.05. You can split as many hairs as you want here, but having it from 0.1 to 0.05 is good enough for me. So let's go ahead and run this. Back in the image viewer, this is the original 196 values, and this is the second one. You can see that there are less images, but there's also a grid here still. It's working as expected. Let's go ahead and take this grid into Photoshop as well and have a look. Here we are in the narrower window. Apologies in advance. I think I went up to 1.75 for B1 and the same for B2. Nevertheless, more data points are always welcome. Remember that I ballparked around 1.5 for B1 and 1.3 for B2. The narrower window is to explore the general area around to see if there are better selections. However, before we do that, I want to make some more observations. If you zoom out and squint, like so, it becomes apparent that you can separate the images into 3 different categories. Anything on the left is desaturated, anything in the middle is saturated, and then everything on the right is a new composition. For the new composition, I want to point out that the images are a lot more cleaner, if that makes sense. If you compare any of the images here, it's not as chaotic, noisy, or in my case, I like to call painterly or sketchy as the images before. So let's just look again. This is the desaturated, and then saturated here, and then Let's go one more block over to the very end around here, and you can see that it's very clean. Depending on what you want, this might actually be the area that you want to look in. However, for me, I want to return to what I have earlier. So this square, and look around. Now that I have delineated the 3 categories as well as pointed out the center right here for the ballpark, we can go ahead and see what exactly we want. You can see that the majority of the images fall into the category of saturated and more clean, but not as clean as the 3rd category, and only one of each for the other categories. Let me just look around to see if there's any more improvements. Remember that we're on a lower increment, so it's 0.05 and not 0.1 like before. For me, I still really think that 1.5 for B1 and 1.3 for B2 is what I'm going to end up using, but depending on what you like, you can choose something that's a bit higher or lower. This one doesn't look that great. It's okay, maybe. This is also fine for me. Maybe not this one, not this one. This second check was more of a precision check, and I'm happy with the output here. Depending on your aesthetic eye and use case, you can choose something in other categories. There are just 1 or 2 things I want to address before going on to the dynamic S values. You may ask, why did you choose preset static S1 and S2 values that aren't the same and aren't 0 or 1? Great question, and I don't want to leave any stone unturned. Here in Photoshop, you can see the plot for dynamic B range with static S1 and S2 at 0. Here in the title, at first glance, you can see that everything is extremely blown out and overexposed. It's basically impossible to do any kind of analysis here. Let's just maneuver around for a better idea. There isn't much to work with, so static S values at the value of 0 is unfortunately a dead end. Now, what about static values of 1 for S? Perhaps 0 was too extreme of a value. Once again, same seed. This time, we definitely have a lot more to work with. However, we're confronted with a separate problem, namely, all of these images seem extremely similar. Visually, there isn't much clarity that distinguishes the 2 groups of images from one another. On this left-hand side, you can see that the design really falls into one kind of aesthetic. Very similar. Pretty much interchangeable in my opinion. And then on the right side, you have something we're a little bit more familiar with. This design here. It's really difficult to see the differences in between the images, I would say. Just a closer look. Yeah, how can you tell? How can you tell indeed? As such, I think there is an argument against having the S1 and S2 values being too low or equal to each other when performing the dynamic B value search. However, this is just my opinion, but it does feel like a pretty solid conclusion. Now that we've dialed in our values for B1, B2 to 1.5 and 1.3, let's go ahead and explore the S values. This time, I've set the S1, S2 values to range from 0 to 1.6 with an increment of 0.1. Also, remember to change the dynamic values to S instead of B, like so. Before we get into the analysis, let's recall that the FreeU paper denotes the S value as the skip connections, which is in charge of passing on details. If the S values are low, the image will be less detailed. With that being said, let's go ahead and look at the most extreme example when the B1, B2 values are static. Here you can see 1.5, 1.3, and S1 is at 0, so this value here. In the first column, when we zoom out, you can see that no matter how much we increase from S2 from 0, going in this direction, the image largely remains flat. So flat, flat. Only around when S2 is 1 do you start to see some definition in the image, albeit it's still very faint. Now how about if we go in the other direction? So let's go up here we'll keep S2 at 0 and this time increment S1. I've outlined it here. So this time we're going in this direction. See how many adornments are gradually added to the image, going from not as detailed over here and then very detailed. You can see here that when S1 is 1.5 and S2 is at 0, you still get pretty good details. Once again, much like the B1 value, the S1 value is the dominant factor here. In addition, the images can be roughly grouped together once again in different categories, beyond a certain S1 value. In this case, S1 of 1.2, you can see that the composition changes slightly. Whereas the character is facing to the left, the character on the right now faces to the right. Let's go ahead and increase the S2 values now. So just heading downwards on the plot, like so. What I see is that when S2 is increased, the image becomes more concretely defined. So there's more of a blockout or definition. And this is the end here. There's a little bit of artifacting going on, but this is a trade-off you're making for more clarity. If you're familiar with Copic drawings or drawings made with Copic marker, this really resembles that kind of aesthetic, whereas S2 values being low reminds me of watercolors. All in all, varying the S1, S2 values and seeing their corresponding results was extremely illuminating to me. From the perspective of a creative, I can definitely see a use case advocating straying from the accepted S1, S2 values in favor of something a lot more stylized, whether it be desaturated, like so on the right, or extremely flat on the left. In particular, these drawings on the left remind me of some kind of Elden Ring aesthetic. However, for the time being, I think going with my original values of 1.1 and 0.2 are prudent. Let's go ahead and do a final comparison now between the original image and the image using the tuned FreeU settings. In my code, I've saved the seed that I've been using for all of these tests in this text file. So here I have the code and the random seed with a seed, and then it's saved in this random seed text file. If I plug in this seed value to ComfyUI, it will give me the original image without any FreeU tuning applied. Let's go ahead and do that. This is the original workflow file. Before we start using this to get the original seed, we have to do two things. First, delete this FreeU node because we don't need it. Second of all, we have to change the seed here. However, if you recall from the API, we changed the seed in the ksampler, not in this random node right here. So we have to create a primitive like that, disconnect the noise, connect this to the noise, make sure it's on fixed, yes it is, and then paste in our value here, and then generate. So we get this image down here, and I don't believe this is reminiscent of the image that we've been working with. In addition, when I press Q prompt, you can see that this value is changing. Why is it changing when I had it on fixed? Let's go again. And it's not changing this time, which is strange to me. I cannot be sure if this is the actual original image. I went back and looked at the API JSON files, and I found my mistake. The issue is that in node 41 for the ksampler advanced, I'm changing inputs and seed, except seed doesn't exist here. I'm supposed to change noise seed. Let's go back to the code and look at the mistake. So the mistake is right here. Ksampler inputs seed random seed. This should be noise seed instead because I'm using workflow node 41 and that doesn't have a seed. It has a noise seed, so this is the mistake. With that being said, that means that this random seed being saved here isn't being used. So if I go back to the workflow and just don't change anything, I should be generating the base image. Here is the workflow once again, no FreeU and no primitive node here. And I should have noticed this is called noise seed, not seed. Everything the same, fixed, let's go. This more or less looks like the image that we've been working on. However, let's do one more sanity check. Let's add in a FreeU node again. FreeU. And also notice that this didn't change at all. Let's go ahead and just do 1, 1, and 1.1 and generate. Okay, that's done generating. It's looking pretty familiar, I would say. Let's go ahead and check again. This is with 1, 1, 1.1, and 0.2. Here are all the generations from the very first trial. Open that one up. And I do believe this is the exact same image. Let's check once more. So this is the image viewer. This is ComfyUI. Image viewer, ComfyUI. So always check your work and be careful when copying the reference code. Noise seed, not plain seed. I will make this adjustment in the code when I upload it to GitHub, but while I'm stuck here, I'm just going to continue using this seed. Here is a tentative image comparison that I've put together of the results we have so far. In the top left corner, we have the original image on the fixed seed, and then I applied a kohya deep shrink on it to see what the effect is, and it's not bad. And then on the bottom left corner, we have FreeU applied to the original image, and this is something we're familiar with. Then I subsequently applied the kohya deep shrink as well to see. It seems that if we use FreeU together with kohya deep shrink, we might have to retune our FreeU values. Personally, I haven't been using kohya deep shrink in my own work. The reason being is in the past we had high res fix and it always gave me very poor results. In this case, maybe it's an incremental improvement, but I do like the effect of FreeU over kohya deep shrink, but of course you're free to use them together. And just for reference, let me show the node graph for this. This is the normal workflow. I just added in the FreeU, and then after that I added in the kohya deep shrink. To add in this node, just double click and type in patch model add downscale, like so. Very simple. We could call it a day here. However, I think it would be a good idea to also tune this for LCM and maybe SDXL Turbo. So let me do that very quickly. The workflow for LCM is loaded in here. To do it, make sure you have a LoRA after your model. Make sure it's set to LCM and then connect it to this model sampling discrete node. Make sure it's set to LCM instead of EPS. And then once you have that, connect your FreeU here. You can also add deep shrink right after this, but I'm going to go vanilla first. This is the grid for dynamic B1, B2 for LCM. You can see here, it's using the same static values of 1.1 and 0.2 that I did in the very first trial for the normal version. And the same issues persist where when B1 or B2 are low, the results are generally quite poor. This is actually pretty difficult for me to find a good value. So just keep going. And it's getting better around here, I would say. Right now, the area over here is already near the end. Those values are at 1.9. which are pretty high. So I think LCM requires your B values to be very high, at least for B1. I think in the end, I'm not going to go with such a high B1 value and instead stick to something here. So this is B1.6. This is B1, 1.6, and I believe B2 is 1.1. I can double check, but I do like this result quite a lot. Yep, B2, 1.1. I believe I will use the B1, B2 values here to calculate the ideal S1, S2 values. Once again, we have a very stylized flat look when S1 is low and when S2 is also low. I feel like this would really fit an animation style or minimalist aesthetic. So let's just drink it in. Very interesting. If you know the video game Bravely Default, this really reminds me of the art style, even though I don't think any of that data is in the training data for this. So you can see the effect of FreeU. Anyway, I looked pretty carefully and found that these S values would work for me. Highlighted them in red. So here we have S1 at 1.1 and S2 at 1.3, and the other one is S1 at 1.3 and S2 at 1.1. Something surprising that jumped out at me was that these values, while not the exact same visually, are reflected across the identity matrix. So if we zoom out, we have a perfect square like that. You can imagine these intersected boxes to be the ones and everything else to be 0. These two values are reflected across this. That means in the case of this bottom left value here, the S2 value is greater than the S1 value, which is a first. I'm not sure if LCM behaves differently, so it might be important to keep this in mind. For the time being, I'm going to settle with this upper right image and its corresponding values. But I'll keep it in mind that the S2 value being greater than the S1 value is also valid. And if we go any further to the right, it becomes very, very harsh. If we go to the bottom corner, get rid of the transpose line, it really feels like an oil painting. If that's a look you want to go for, go ahead, but it's not really for me. Since this is LCM and I'm probably going to be working with it in real-time painting or something like that, I want it to be very loose and sketchy. And these are both results that I can live with. Here is an updated comparison with the finalized tuning values. After that, we have the LCM on the original seed. And on the right, we have FreeU applied to LCM. So you can see the newest addition on the most bottom row. I want to do one more comparison, which is using the SDXL Turbo model. However, SDXL Turbo in its current form exists as a checkpoint and not a LoRA. To do the comparison, we'll have to extract a LoRA from SDXL Turbo. To extract the LoRA, I'm going to be using Kohya SS GUI by bmalte. Once you're in this main page, just go to Utilities, and then on the very right, there's LoRA. Then there's a section here showing you all the types of LoRAs that you can extract. For me, I'm going to be using extract LoRA. Here, I'm going to make some changes. First of all, I want a higher dimension. Clamp quantile and minimum difference are recent additions, so you can just leave it as is. Float precision, you can keep it as float or FP16. Let's go with FP16 for now. Next, we have to enter 3 different paths here. Since SDXL Turbo is fine-tuned from SDXL 1.0 base, this is what you'll put in this area. So let's do that. You can see it show up here. Next, we need the fine-tune model, so I assume you've downloaded SDXL Turbo already, so this is where it would go. Done. Very easy, nothing fancy. Lastly, we want to save our LoRA, and that's done here. Just have to check this SDXL box, and we're good to go. I'm going to go ahead and run this, and then show you what's happening in the PowerShell. I'm going to go ahead and click on this button, and at once, you can see this happening. It's sending this script. You can see here after around 2 minutes, it's done extracting, and we can go ahead and test out our LoRA here. Back in ComfyUI, to use it, just have your checkpoint of choice here. Load your LoRA in. For me, it's going to be this 256 Turbo FP16, and then same old clip to clip. And then I have FreeU disconnected for now. Same seed that I've been using the entire time, 4 steps, and using Euler Ancestral for the sampler. Since this is a LoRA, you can choose any scheduler you want. If you're using the SDXL Turbo base model, I think there's a special scheduler for that one. So let's go ahead and try it out. Okay, and it's done generating. This is without FreeU applied, so we'll have to do some tuning for this. However, just to show you the real-time capabilities, I'm going to change this to randomized for now and just rapid fire generate them. Yeah, see how fast it's going? It's even faster if you don't use this image save node. And let's just do one more. Yeah, so pretty cool. It is faster, but anatomically, I don't think any of these are working out well. The torso seems way too big. It definitely seems a lot less coherent than LCM, albeit the image quality is superior in my opinion. Here is the dynamic B-value grid once again for SDXL Turbo LoRA. Nothing changed, still using the original S1, S2 values of 1.1 and 0.2. I found two initial results that worked for me, which are here. These two red squares, this one, and the other one down here, this one. The one that I ended up going with is the one right here, which is B1 at 1.8 and B2 at 1.3. I did like the other one, which is B1 at 1.6 and B2 at 1.9. So to be sure, I went back into ComfyUI and did some A and B generations, and those values performed poorly on average. 1.8 and 1.3 it is. If you are curious on how it looked on the lower B1 values and B2 values, yes, it's basically very watercolory, and in my opinion, not very good. Let's just stay with the tradition of having the 1 value be greater than the 2 value with this one. If you're curious about what some of the generations looked like with varying B1 and B2 values, here are some of them. You can see that SDXL Turbo seems to fall into the trap of the earlier SD 1.5 versions, where depending on the image size, you have repeating people, more than one person, extra heads, extra arms, that kind of stuff. I felt that by using B1 of 1.8 and B2 of 1.3, I avoided some of these issues. However, they were still prevalent in maybe 20% of the images. This time we're varying the S1, S2 values like always while keeping the B at 1.8 and 1.3 that I said before. On the left hand side with the low S1, S2 values, it's pretty much a disaster. The anatomy is all messed up and there's duplicating heads, which is a very classic Stable Diffusion 1.5 error. However, if we keep maneuvering to the right, which is where the higher S1, S2 values are, I did find some that were very good for me, and this one is with S1 of 1.6 and 1.4. You're also free to go with this bottom one, but I think there's a little bit of a subtle difference, not too much. I just prefer the look of this one. So there you have it. Let's finish up with the recap. Last we left off, I added the LCM and FreeU LCM here. But now we have a new addition with the SDXL Turbo LoRA, and you can see there is quite a substantial increase in quality. It's basically night and day, whereas it might not have been so apparent with LCM. And then we have FreeU on original, which is a markedly good improvement in my opinion. However, you also have the option of using the Kohya Deep Shrink, and it seems that using Kohya Deep Shrink and FreeU is probably not a good idea. There are times where you can use FreeU, and it does seem like it's always going to be a good idea to use it. However, your mileage may vary and you may choose to go with another option. So there you have it, in-depth experiments across different samplers and models. Before I finish up, let's not forget to thank the channel patrons. Thanks for watching and bye.